functions are the big kahunas of graphs. They are the graphs that I expect everyone to know and love and know what they are and what they look like. The overall shape is really what we're interested in. So, for the first thing, you guys are going to have a couple of minutes. You're welcome to use your calculators. So, example 1. Use your calculator. If you need, you might not need a calculator. To sketch the graph of each function type, label 3 points on each graph and determine the domain and range of each. So, for example, the first function, f of x equals x. What is that graph? Yeah, the slanty line. Often called the identity function, because the x and the y are identical. So I'm going to label some points there, 0, 0, 1, 1, and 2, 2. And we look, domain is how far left and right the graph goes. So how far left and right does the graph go? Negative infinity to positive infinity. And the range, how low does it go and how high does it go? Negative infinity to positive infinity. So for each function, you're going to label a few points and write down the domain and range. And these are all basic functions that we want to know and love really, really well. So I'm going to give you guys just a couple of minutes to copy those, write those down. All right. You will also find these functions and a couple others on page 70, I believe, of your book, which you'll see in just a little bit. Yeah, page 70. Again, these are the basic 6 functions that you need to know and love. All right. Whoa. All right, here we go. Moving on. You can finish drawing those later. You can finish that later. Example 2. Write the equation of the linear. Linear is an important word there. Write the equation of the linear function f, for which f of 0 equals -1 and f of 5 equals 8. I actually gave you this question on your review for your last test, which is always amusing to me because I think that was question number 4, but all of you were able to do question number 3 just fine, and then you get to question number 4, which is actually easier, and everyone's like, I don't know how to do it. It is exactly supposed to be an ordered pair, yes. So when we have function notation, it's important for you to remember that all we have is an input value and an output value. And if you have an input and an output, then you have an ordered pair, which means we have the ordered pair 0, -1, and 5, 8. And what do we need to do in order to write the equation of the line? Find the slope, sure. The slope is y2 minus y1 over x2 minus x1, which would be 8 minus the -1 over 5 minus 0, or which equals what? 9/5. And once you know the slope and one of your points, what do you do with your slope and your point? You put it into point slope form, which is what? What is the point slope form? Y minus y1 equals m times the quantity, x minus x1. Very good. So I'm going to plug in my y minus a -1 and my m of 9/5, my slope of 9/5. Now I'm going to distribute and subtract the 1. And there is my equation. Can you check this equation? What would you do to check it? Yeah, plug in the equation into your calculator. Calc. Plug it into your calculator and then use trace to check your ordered pairs. And you want to check both ordered pairs to make sure that your line passes through both ordered pairs. Super easy to do, absolutely worth checking. All right, questions on that one? Try this one. Wait, what? Here.
Sorry, I like to cut them writing in.
Oh, Nicholas.
Alright.
Alright, here we go. Alright, this is a graph you might not know. I will tell you in all honesty, I was a math major in college. Never saw a greatest integer function until 3 years ago when I started teaching here again. Wow. So you'll probably never need this again. I'm just going to be all honest there. Okay. This is a greatest integer function. This is the notation for the greatest integer function. It's a kind of a deceiving name. The way I draw that is I make a bracket with an extra bar. That's it. It's like a bold-faced bracket. Okay. And the greatest integer function is part of the step function category. So this is an example of what we call step functions. Now, step functions are functions that I had seen before, but I've never had the greatest integer function. So it's, rare. All right, we're going to talk about the greatest integer functions. What does it mean? The greatest integer of a number equals the greatest integer. What's an integer? A number. Brilliant. What kind of a number?
Not a negative. It's not decimal.
It is the positive and negative whole numbers. -3, -2, -1, 0, 1, 2, on and on. The positive and negative whole numbers, ladies and gentlemen, integers. Woo! A bracket with an extra bar.
Oh,
yeah. All right, so the greatest integer, here's the important part, less than or equal to the number. That is what the greatest integer function is defined as. The greatest integer less than or equal to the number. So if I wanted to graph the greatest integer function, then maybe I'm going to do a little table of values. And I'm just going to graph a number for x and then figure out what the greatest integer for that x value would be. Let's see. I'm going to start with x is 0. So I want to know what integer, what's the greatest integer less than or equal to 0? 0. Yeah. And I'm going to try like 0.25. Greatest integer of 0.25. What's the greatest integer less than my number 0? Sure. And like 0.5, what's the greatest integer of 0.5? Still 0. And I could do 0.75. What's the greatest integer of 0.75?
0.
Still 0. What's the greatest integer of 0.99?
0.
Still just 0. Because it's the integer less than or equal to the number. Okay? What's the greatest integer at 1? 1. Because that's the integer that's equal to the number. Okay? What's the greatest integer of 1.1? Just 1. The greatest integer less than or equal to the number. Okay. So if I were to graph this, I'm gonna make a little graph here. Real easy little graph. And when x is 0, my output is 0. So I have a nice big dot there. At 0.25, it's still just 0. At 0.5, it's still just 0. And at 0.99, it's still just 0. And in fact, for any x value between 0 and 1, my graph is just 0. The output is 0. What happens when x is 1? It goes up to 1. So at 0.99, we're still at 0. And at 0.9999999999999, we're still at 0. Okay, which means that's an open circle there, yeah? And then at 1.2, we're still at 1. At 1.5, we're still at 1. And in fact, everywhere between 1 and 2, our greatest integer function is still just 1. What happens when x is 2? It goes up to 2. Okay, which means we've got an open circle at the end of that. And you can see why, if you continue the pattern out there, you can see why this is called the classification of step functions. Do you see the steps? Yes, okay. And it would continue the other way as well in the same pattern. So this is the graph of the greatest integer function. Ladies and gentlemen, you do have this on your calculators. So I wanted to show you how to do that on your calculators. So you can go to your y equals menu, your graphing menu. Delete, yes. Okay, so both of them are kind of similar. For the TI, we need to go to the math menu. So go to the math menu. Under num, int is the greatest integer function. So math and num, int, integer. So greatest integer of x. On the Casio, it's very similar. We're going to go ahead and press option and num. Option and num, and again, int, greatest integer of x. Okay. And then if you graph those, whoops, you can see, now the Casio, clearly the output isn't quite as nice. You need to know that those are just straight line segments. But there you go. Which means that you can also use the greatest integer function if you were trying to evaluate. You could just, again, use that num and int menu on your regular home screen as well. All right. So now that we know the greatest integer is the integer less than or equal. Yeah, your calculator is older, so it's connecting them, but you have to know that they're not really connected. That's why we graphed it by hand. All right, last one, example 4. Evaluate the function for the indicated values. Evaluate the function for the indicated values. Option. Oh, yeah. So right there, int. Now put in your X. I would use parentheses. All right. Again, the greatest integer means the integer less than or equal to the number, which is weird. That's why I think the name is just inherently confusing. It's not the greatest integer. It's actually lower than the number. Okay. It's the number, the integer less than or equal to x. They want us to find f of negative 2.5. What does that mean? Plug in for x, sure. So f of negative 2.5 would equal, plugging in for x, negative 2.5. And so I want to figure out this whole greatest integer of negative 2.5. This is a tricky question. What is the greatest integer of negative 2.5? Negative 2 is what you think, but it's not right. Let me draw a number line. 0, negative 1, negative 2, negative 3. So when in doubt, graph it out, right? So I'm going to go to my number line because right here is my value of negative 2.5. What is the integer less than? Negative 3, right? So that's tricky. Less than is always to the left, right? Okay. So kind of tricky. It's important to think about. The greatest integer of negative 2.5 is the integer less than, which is to the left, would be negative 3. Plus 3 gives us 0. All right? Tricky, tricky, tricky. Letter B here, we're going to plug in positive 2.5. So the greatest integer of 3 times 2.5 minus 1. Again, this we got to simplify inside first. So 3 times 2.5 is 7.5. Minus 1 is 6.5. What's the greatest integer of 6.5? 6. And again, if you're thinking on a number line, 5, 6, 7, 6.5 is right here. The greatest integer less than the number would be 6. Okay. God bless you. All right, ladies and gentlemen, you can do these calculations on your calculator as well using that same menu, num and int, if you wanted to do it on your calculator to double check, okay? So you have the integer, greatest integer function on your calculator, and you can use that as well. All right, ladies and gentlemen, do you have questions for me? All right, you guys can